Hello and welcome to NeuralCraft. This is our third tutorial in our playlist Machine Learning Hands-on with Python. So far we have studied about data understanding and data visualization. Now comes the most important part, that is the data pre-processing. So many machine learning algorithms make assumptions about your data. It is often a very good idea to prepare your data in such a way to expose the structure of the problem to the machine learning algorithms that you intend to use. In this tutorial, you will discover how to prepare your data for machine learning using Scikit-learn, a powerful library of Python. After completing this lesson, you will know how to rescale your data, standardize your data, normalize and binarize your data. So first of all, let's understand about the need for data preprocessing. So you almost always have a need to preprocess your data. It is a required step. Why? Because difficulty is that different algorithms make different assumptions about your data and many require different transforms. So when you follow all the rules and prepare your data, sometimes algorithms can deliver better results without preprocessing, but this is not almost always the case. You will get some messy data. In that case, I would recommend creating many different views and transforms of your data by yourself and then decide which attributes are causing problems and then decide which preprocessing technique which we are going to study in this lecture will be helpful to restructure and organize your data. So first of all, what is the data transform? So data transform are basically the different techniques that we use to either scale our data, bring it to a proper zone, removal of the unknown terms, and also to make either data are discrete, you can also make your data fall within a certain range, not by magnitude, on also on the basis of some threshold. So we will discuss all the techniques one by one. So the four major types of transforms are rescalation of your data, or we can say scaling. Another one is the normalization of data. When we combine normalization with another technique which I will tell you shortly, then you are going to get a standardization of data. Apart from these basic techniques, there is also a fourth technique which is known as binarization. Binarization helps you to bring your data between different slots and assign them a common value, so that a number which falls within certain range can get a common value based on that certain range. So first thing is the rescaling of our data. So when your data is comprised of attributes with varying scales, many machine learning algorithms can benefit from rescaling the attributes to all have the same scale. So in scaling, you can do one thing. If you have most of your data points in all the attributes lying between the range of 0 to 1000 and some attributes in the range of 0 to 88, you can either bring them all of them in the range 0 to 100, or you can scale them from you can scale the second parameter whose range was from 20 to 88. You can either upscale it or you can downscale the first parameter whose value was lying from 0 to 1000. By rescaling them, you will get a common range in which when you are going to train your model, you are going to get better result. So rescaling is just simply going to help you better results after running the common algorithms, like KNN, k nearest neighbor, is one of such algorithm. It helps in optimization, like when we are going to use gradient descent, you will learn about this. So the scikit library offers us a class known as MinMaxScaler, which helps us to decide a range and then scale our data within that range. So now let's move to next data transform technique, which is known as normalization. So normalization is going to bring each and every attribute within our data set to have values between 0 to 1. That means all the vectors are going to have a unit norm. So it helps in cases where we have a sparse data sets and it is also beneficial for the algorithms which uses distance as a matrix for calculating the different scores. So we can implement normalization with the help of Scikit-learn tool. The class is normalizer. So let's move to our VS Code and implement both the data transform techniques. So first I have created this another file which is data preprocessing v2, and here I am going to select the kernel as I'm going to select virtual environment my kernel, and I'm going to import pandas as PD, and I'm also going to import numpy, because these are the main libraries that we are going to use throughout our this data preprocessing and machine learning. We are not going to go anywhere uh, before importing these libraries. So now I am going to load the data set using read CSV function. Here we have to pass in our relative path, so just paste it here, and let's have a peek at our data set. So here I want to show you something. So we are going to check the minimum and maximum values for all the attributes. So I'm going to write one function for call in data dot columns. Now I'm going to print the minimum and maximum value for the each and every column. So here I'm just going to write two print statements. Print f min value is going to be minimum value for the column is going to be uh, data of call dot min, and similarly I'm going to write the maximum value. So this is auto completed. These two values I need to check for each and every attribute. So as you can see, for pregnancies we have values lying from 0 to 17. For glucose we have values lying from 0 to 199. So you can see for insulin we have range of 0 to 846. So this data is not does not belong to a same range. Now we are going to bring this data to a common range with the help of scaling technique. So first of all, let's create a markdown for our scaling, so we can keep our code structure clean. So here I am going to import uh, Scikit-learn dot preprocessing MinMaxScaler. So we are going to use MinMaxScaler only. Now I am going to do some data separation. So for that I need values. So I am going to store values as data dot values. So what values variable is going to store is storing it is going to store the data as numpy arrays. So this is nothing but each and every row in our data. You can see 6 1 4 8 72 and going up to 1. In our here you can see 6 1 48 72 and it is going up to 1. So it is storing each and every row as a single vector. So now we are going to create x and y separation here. So we are going to use slicing operator, and we are going to follow whole range, and the attribute range is going to be 0 to 8. So we will have first, and here instead of arrays we are going to use values as variable. So for in S we are going to store all the attributes like pregnancies till age, and the outcome, which is the classification variable or the categorical variable, we are going to store it in another uh, which is going to be y, another variable y. So here we have to now span across all the range, sorry, we have to span across all the range, and the attribute which we are going to store here is the last attribute, index that 8. Now I am going to initialize our MinMaxScaler. So here we are going to use MinMaxScaler, and then for the feature range we are going to choose a common range from 0 to 10. So what is it showing? Oh, we have to import it. Still imports sklearn.preprocessing. uh, Here it is going to from sklearn.preprocessing import MinMaxScaler. Rerun this cell, and now here make it to a common range. Yeah, and now we are going to fit and transform our data. So rescaled version of apps is going to be scalar dot fit and transform. So fit and transform function is going to initialize this method with the feature range, and provided with the data, it is going to transform the ats numpy array to fall within this feature range of 0 to 10. So if we just have a look at our data scale rescaled ats, we will see a range is a range is showing here. So 3.5, 7.7, 7.5, and all. So if we just we are getting the all the range from 0 to 10. Now if we just change this to 0 to, let's say, 1, let's see what is going to happen. Running the both the cells, and now you can see the range has shifted. Now all the values are from 0 to 1 only. So now we are going to move to the next data transform technique, which is data normalization. So normalization. So we are going to import sklearn dot pre-processing. From sklearn dot pre-processing import normalizer. We are going to use initialize it normalizer, and by default we are going to use L2 norm only, which is nothing but the square distance between mean square distance between the 2 points in a vector space. So it is by default L2, so we are just going to leave it that way. And the variables that we are going to use reuse again are values, which contains the values from our data in a vectorial form or numpy array form, and then we are going to split them into x and y. So we will transform our x variable. So here we are going to create a scalar which is going to be normalizer initialization, and then using the fit and providing our data to it, and then we are going to normalize x, which is going to be fit dot transform. Now we will just have to print and check normalize apps. So here you can see we are getting the data in the range from 0 to between 0 to 1. We can do one more thing. We can control the precision with the help of the numpy library. From numpy import set it is showing one error, set precision points, set or we can say set print options, and now set print options and precision. We can give how many decimal points we need to show here. So by default, let's say we want 3. So after running this, we need to just paste this line here. We can just do print normalize x. So this has just constrained our constrain the precision of our data to 3 decimal points only. So here you can see all the values which are we are able to see here lies within the 0 and 1 range. We can compare this result with the previous result. So first of all, in scalar we have this rescaled x, and here we have normalized x. So just print both of them. Rescaled x, we are going to print the first vector. For normalize x, normalize x 0, zeroth vector only. So you will see here we are getting different values. So here it is 0.59, but here we have 0.403, 0.354, here is 0.196. So why is it happening? Both the techniques are bringing our data to a common range of 0 to 1, but scalar is using different approach, and normalization uses different approach. So here what is happening is where our values, so both are transforming these values only, but the major difference comes what is the approach they are following. The min-max scaler is going to find the minimum and the maximum value within each and every attribute. It works vertically downward, so it is going to find the minimum and the maximum value for each and every attribute here. So within this within our data, the first attribute is nothing but the pregnancies. So it is going to find the minimum and maximum value of the pregnancies, and then going to divide each and every value with that value only. So it is going to divide all the attributes with the 17 only. So 6 by 17, 1 by 17, 8 by 17, till till the last value of like the 767th row. But in normalization, as I have already discussed here, in normalization we try to achieve a vector of length 1, so it works horizontally. Instead of taking values vertically from the common attribute in each our data point, here we find out the length of the vector for each and every row in our data. So here by vector I mean the set of attributes which are we are treating in X for each and every at each and every primary index. So at primary index we have this vector 6 1 4 8 7 2 and all. We can print it X of 0, values of 0, sorry, values of 0. So values of 0, the vector comes out to be 6 148 72 35 0 33 0.627 50 1 and 1.1, only 1. So you can see we have to find the square mean square distance for this squared root distance of this vector, and then after finding the norm which is also the length of this vector, we have to divide each and every value for all the attributes within that data point, and we will get the normalized value. So here what we are going to see is we are going to see that value. But in rescaling we were seeing a different methodology. So it was working vertically, but the normalization works horizontally by taking the help of the norm of the vector. So this is all for the normalization and rescaling. And now let's move to another data transformation technique, which is standardization. So standardization helps to transform attributes with a Gaussian distribution and differing means and standard deviation to bring it to a standard Gaussian distribution with the mean of 0 and the standard deviation of 1. It is more suitable for techniques that assume a Gaussian distribution in the input variable and work better with rescale data, such as linear regression, logistic regression, and linear discriminant analysis. We can implement this using the StandardScaler class within our SQL preprocessing. So here we are going to create another section which is going to be standardization. From sklearn from sklearn we have to import from preprocessing we have to import StandardScaler. Now we have already have the values, we already have x and y variable, and now we are going to create another scalar. We can name it standard scalar and initialize it with standard scalar and fit our data to it. We have fit our variable, and now standard x is going to be standard scaler dot transform. It is going to transform our data x. Now we can set our precision points. So set print point, set print options, and precision to, let's say, 3, and now print standard x. So as you can see, we are seeing some vectors with negative value also, because if we move to our here we are seeing one distribution in which there are also values in the negative x-axis and also in the positive x-axis. So by standardization, we are going to shift our data from any non from a non-zero mean to a zero mean. So we will get this bell-shaped curve only, which is nothing but this Gaussian curve for having zero mean and unit variance. The formula which is used for calculation is this. So here x represents our original value of the feature, and mu is going to represent the mean value of the feature. We subtract the mean value from the original value, and then we divide it by the standard deviation of that particular feature. All both these values are calculated, we can calculate them separately, or these are pre-calculated within this standard scalar function only. So after we have calculated this value, we replace the original value with the z value. So this is the standardization. This is how standardization is performed. So now let's move to next data transformation technique, which is known as binarization. It is also known as thresholding because it helps in converting values to a certain range. So the data in binarization can be either represented by 0 or by 1 based upon a threshold value. Suppose here we have a machine learning, we have a neural network which performs a forward pass on the input varying from x1 to x4. So after performing forward pass, it is giving us some probabilities which are within the range from 0 to 1, and these are continuous. So to bring something meaningful from this data, there is a need to convert this into a form, into a binary form. So this can be done with the help of thresholding. So here we are going to decide a number below which and equal to which we are going to assign all the values to be 0, and above the threshold we are going to decide it as 1. So to make the information more relevant and making the crisp decisions, we can use binarization. So and also it is going to help a lot in feature engineering, where from a particular data or from a particular attribute we have to extract information based upon our business logic. So binarization is a helpful technique. We can implement it using the Scikit-learn tool, or we can implement it by our own, because pandas provide us flexibility to create our own function and then apply it with its powerful methods like dot apply or dot map. So here I am going to just give you the demo using binarizer, but you can implement this from scratch also. So here create another section which is binarization. So here from standard scaler, sorry, from sklearn.preprocessing, from sklearn.preprocessing, we are going to import binarizer. Now we have to just initialize it. So we will use binarizer and threshold. Here we have given a threshold point 0.0. Let's first use it with the threshold of 0.5. Now transform our data, and then we will use a binarize it is going to be just binarizer dot transform apps, and set our precision points to 3, and just print this one. So here you can see it has converted our data to almost ones. It contains almost all the values as ones, because here it is not just going to, like you can see here in binarizer, it has decided to get some values as 0, get some values as ones. So if instead of this transforming it on apps, we can pass in the another vectors, like from here we can pass the standard apps. So if we just pass here standard apps and see, then we see our results, and we also have to transform it on apps also, standard apps. So here you can see uh, in this case we are getting a different result. In the previous case where we had only apps, we were getting almost all the values as ones. This depends totally on our data. In the previous, in the when we are using apps here, so if I put apps again here, the result we are getting is almost every value is 1, because in apps, in the real actual example, apps had these kind of values 6, 148, 72. All these values are greater than 1. But in standardized vector, what we had is we had some negative values, all the values between -1 to 1. So uh, a threshold of zero point 0.5 is more meaningful to us when we have a range of the data on which it is applying within a relatable range. So here the range is -1 to 1 and the threshold is zero point 0.5. So most of the data which is either going towards below 0, and most of the data which is above 0, 0.5, uh, they are not exceeding the maximum cap of 1. So this will give us a lot of data points with 0 and 1s. But in the when we are using these original data, most of the values are already above 100 or above 50. So this is, there is no point on transforming this on raw data. So as you can see, if we have any particular data pipeline in which we have already normalized or standardized our data, and then we need to perform some kind of feature engineering, then using the binarization we can perform that. So here if we am just going to use standardized apps and transform also on our standard apps only, and see our result, we will see a better result here. What do I mean by better is we are getting better use of this threshold. If I am just going to shift this threshold to zero point 0.9, you will see almost all the values are converted to 0, because tweaking this threshold tells us about the hyperparameter. Threshold is a hyperparameter which we can tune. Uh, in machine learning, in deep learning, when we are when we have output from a neural network, mostly in case when we are getting probabilities as output, then we need to get it when we need to perform some classification, we use the sigmoid function, which also utilizes this threshold. And there also we have the threshold as a hyperparameter. So in binarization, we can extract some important information from the data. So that is all about the different techniques that are used for data transformation. We have learnt about scaling our data. Not only 0 to 1 range, we can scale data to any specific range we want. Like we can scale it to some -50 to some -21, or like from 1000 to 8000. Rescaling is just helps you to scale your data to a range in which you may be able to derive more information. Standardization involves shifting our Gaussian curve from any non-zero mean to a zero mean and unit variance distribution, by subtracting the mean from the original feature and then dividing each and every value with the variance, or we can say standard deviation. Normalization helps us convert our vector, our data in our data set. It helps to convert each and every vector to achieve a norm of 1, and in this way each and every attribute within that vector is going to assume a value from within the range of 0 to 1 only. In rescaling, the scaling happens attribute wise. In normalization, scaling happens vector length wise. Uh, so in binarization, as you have already seen, it converts our data to zeros and ones simply based on a threshold. So this is all for this tutorial. We'll meet again with our next step. Thank you.